In this presentation, we shall discuss some of the interesting facts on electrostatics. Electrostatics is the branch of physics dealing with charges at rest and the properties of the charges which are at rest. Static electricity was first observed by Thales of Miletus in 600 BC when he found that umber, a kind of a stone, when rubbed with fur, acquired the property of attracting tiny pieces of sawdust, etc. Electricity produced by rubbing is called frictional electricity. Since the charges so produced are at rest, it is also called static electricity. Charges are produced by transfer of electrons. In 1600 AD, Dr. William Gilbert, court physician to Queen Elizabeth of England, published the book in which he made an account of all the experiments and observations made so far in the field of electrostatics. Gilbert found that there are two kinds of charges and that like charges repel and unlike charges attract. He named the two kinds of charges as resinous and vitreous. Charges acquired by umber or ebonite when rubbed with wool or fur was called resinous, and the other kind of charge was called vitreous. Then Benjamin Franklin, an American scientist, introduced the convention according to which resinous charge was called negative and the other was called positive. Some of the important properties of electrical charges. Conservation of charges. The total charge in any system is always conserved. That is, net charge can neither be created nor destroyed in isolation. Charges can only be produced or destroyed in equal and opposite pairs. The total charge before and after any reaction remains the same. This is the content of the law of conservation of charges. Then another important property of electrical charges is quantization of charge. That is, the charge present in any body is always the integral multiple of the fundamental charge, that is the charge of an electron, whose value is 1.6 into 10 to the power of minus 19 coulombs. No body can possess fractional electronic charge in the macroscopic world. The next property is relative permittivity. It is defined as the ratio of the force between two point charges separated in vacuum to the force between the same two charges separated by the same distance while kept in some medium. That is, epsilon r is equal to F0 by Fm, where F0 is the force between the 2 point charges in vacuum and Fm is the force between the same two charges separated by the same distance in some medium. The other important property is the principle of superposition of charges. It states that when there are a number of point charges, the net force on any one of the charges is equal to the vector sum of the forces due to the individual charges. That is, the vector sum F1 is equal to F12 plus F13 plus F14, etc. That is, force on charge 1 is equal to the vector sum of the force on charge 1 due to the charge 2, charge 3, charge 4, and so on. The definition of a coulomb. 1 coulomb is defined as that charge which, when kept 1 meter apart from an equal and similar charge in vacuum, repels it with a force of 9 into 10 to the power of 9 newtons. Now, the concept of electric field has two ways of realizing it. One is qualitatively, the other is quantitatively. Qualitatively considering, an electric field is the region of space around a charge where it can exert a force of electrical origin on another charge. Quantitatively, the intensity of the electric field at any point is defined as the force exerted by a unit positive charge by a positive test charge kept at that point. In mathematical equation form, it is written as E is equal to F by Q naught, where the limit Q naught tends to 0. That means F is the force on a small test charge Q naught. The electrical lines of force. The electric field is generally represented by certain imaginary lines of force such that the tangent to the line of force at any point gives the direction of the electric field at that point. A positive point charge free to move will move in the direction of the electric field, and a negative point charge will move in a direction opposite to the direction of the electric field along an electric line of force. The lines of force to represent uniform electric field are shown below. So these are all the electric field lines of a uniform electric field, where all the lines are parallel and equispaced. Now this is the representation of the electrical lines of force due to a charge Q, and this is a negative charge less than 0, and this is a representation of the electrical lines of force due to a point charge Q greater than 0, that is a positive charge. Properties of electrical lines of force. The electrical lines of force start from a positive charge and end in a negative charge. The tangent to it at any point gives the direction of the electric field at that point. Electrical lines of force never intersect each other. They tend to contract longitudinally and expand laterally. They always enter or emerge normal to the surface of the charge, and they are always close together in the region of strong electric field and far apart in the regions of weak electric field. Electric dipole. A system of two equal and opposite point charges separated by a very small distance constitute an electric dipole. Electric dipole moment of a dipole is defined as the product of the magnitude of either of the charges and the distance between the two charges. And the electrical dipole moment is given by P is equal to 2L into Q, where 2L is the distance between the two charges and Q is the magnitude of either of the charge.